So I have this written down for the blue. Now I need to go ahead and figure out that for the orange. So my orange is a negative 0.5. So I got to pull up my negative one, and then for you, that's on your left-hand table. And I need to look at a negative 0.5. Well, negative 0.5, it's really a negative 0.50, so that's right here, with the second one being an O0, so I'm going to go ahead and write that number down. Whenever you're looking for what is in between, all you want to do is subtract the two numbers you get out of the middle of the table. So I need to take my blue and subtract my orange, and when I go ahead and subtract these, I'm going to get my answer. So use your calculator if needed. And when you do that, we get answer C. Now here we are looking for what is above. Remember, table A always tells you what's below. Whenever you're looking for what's above, you just go 1 minus your answer you get in the middle of your table. So we're going to start out with our z-score here. We're going to go our z is equal to our data value of a 125 minus our mean of a 110 over our standard deviation of a 15. So we get 15 over 15, which ends up being 1. We need to then go ahead and look at our table because this is only our z. Look at our table. Look for a positive 0.1. Well, a positive 0.100 is what we have here. Positive 1.00. So I then need to look that up here. Positive 1.00 would be right here. So I get a 0.8413. That is what is less than my data value. But since I am looking for above, I need to then go 1 minus that value. And then in that case, I get approximately what this one here is. It's not exactly that, but it's the closest one that we have. So I need to figure out the z-score for my 120. I need to figure out the z-score for my 135. Find both of those in my tables in the back of the book, and then subtract the two numbers I get from the middle of my table in the back of the book. So I'll go my 120 minus my mean over my standard deviation. And so then I end up getting 10 over 15, which is 2/3. And remember, I always want to go to 2 decimal points. I'm going to do the same thing for my orange one here. And go ahead and divide by 15. And I get my z-score to be a 1.67. Always going to the nearest 2 decimal points. So now I need to go ahead and find each one of these on my table. In this case, they're both positive, so I get them from the same table. For you guys, it's the table on the right-hand side. And I need to go ahead and find each one of these. So when I look at this first one here, I need to find that 06 on the left-hand side, go all the way over to the 07 column, and I get this. Then for the orange one, I need to go to the 1.6 on the left-hand side, still going over to the 07 column, and I get this. Now we need to go ahead and do a little bit of subtraction. So let me get rid of my table so we can see our... We are looking for what proportion. Whenever you're looking for a proportion or a percent, it's always positive because we can't have a negative percent of people or negative percent of babies in this case. So since we can't have a negative, that means you're always having to take the bigger minus the smaller. Minus the smaller. Do it in your head or use a calculator. Get your answer, and then that's what we're looking for. Now, occasionally, you're going to have to modify this answer a little bit. But since we are looking for a proportion, this is what we're going to be. If it had said look for a percent, we would have to take this last answer and move our decimal point over 2 spots. But it says proportion, so that's it. We're done. We move on. Now, in this case, we're looking for the top 5%. So that means when we're ever given a percent or a proportion, it's a reverse z-score problem. So we're going to start off with that formula. And we're going to go ahead and plug in our mean, plug in our standard deviation, but then we got to go ahead and find our z-score from our table. So to do that, I need to go ahead and pull up my table. Now keep in mind, I'm looking for the top 5%. My table always tells me what's less than. I know the top 5%, I got to think about, well, what's less than? If the top 5% is what I'm looking for, means 95% is below, so I need to find a 0.95 in the middle of my table. So I look for a 0.95 in the middle of my table. And in this case, I would get this right here. Now, in this case, I have one that's 5 below. I have one that's 5 above. Normally, you're not going to find exactly what you're looking for, a 0.95. Normally, one's going to be slightly closer than the other. So in this case, we could probably choose either one, would not make a difference. I'm going to actually go ahead and write the z-score down, being halfway in between, which would be a 1.6. Right in between the 4 and the 5 would be a 4, 5. So think of this as a 40, this is a 50, and halfway in between 40 and 50 is 45. So that's my z. So now I go ahead and put those in. I have my mean, I have my standard deviation, I have my z. Just type them all into my or fill them into my formula here. And then I'm going to use my calculator. So that's what we're going to have for our top 5%. So any box that's at a 34.1515 ounces or above is considered overweight. So now let's take a look at underweight. What percent or proportion of the boxes is underweight? And underweight, it says, is less than the 32. So here we're given a data value. We're not given a percent, so this is just a normal z-score problem. So we'll go ahead and go z equals our data value 32 minus our mean of 33 over our standard deviation of 0.7. We go ahead and type that into our calculator. Always making sure we go to the nearest 2 decimal points, so that gives us a 1, 4. Whoops, I got a 1 here. Let me change that to a 0. So a negative 0.14 is what I need to find on my table, table A, in the back of your book. So I pull that up. It's negative, so that's on the left-hand side of the page. And it's negative 0.04. So I need to find that negative 0.1, which is here. Go over to the 04 column, which is here. And I come down and I need to find that right here. So I have a 0.4443 from the middle of my table. Sorry about that. I just realized I messed it up when I did my division. It should be a negative 1.43 in this case. So we need to go ahead and find that on our table. And we're looking for what's less than that. Remember, what's less than is always what our table tells us. So what we have right here is our answer that we're looking for. And this overweight problem is what we did up here initially. And so what we did up here is what we had for our answer down below here, which I ended up getting this, which does not match what I had written here. Sorry about that.